Hey, I just wanted to talk about some cell phone DC electronics, um, the foundation of which is Ohm's law. Ohm was a scientist who defined this law that voltage, resistance, and current are in relation to each other. I also have ground up there because ground is important in understanding uh, the overall sense of how this all works, and also because a lot of teachings don't talk about ground. And I think ground is one of those things that doesn't get a lot of coverage. And so understanding ground is a huge part of understanding the repair of cell phones. So voltage is pressure. You're pushing pressure on the electrons in your circuit. Resistance is not reverse pressure, but when that voltage meets something that it can't necessarily push through as easily. So in sense of electronics, there's things that are conductive and there's things that are semiconductive. A conductor is something that easily passes electricity through it. It has a valence electron, an electron in its shell, outer shell, that easily exchanges between the different atoms. And a semiconductor is something that a lot of times has been coaxed into being somewhat conductive that may not have been in the past. So a lot of times you hear of semiconductor and those things like a resistor, much like a resistor you would see on a cell phone, that resistor was non-conductive at one point, was dipped in acid and treated so that there's molecular holes. And those holes provide a means for electricity to pass through. But it's not as conductive as, say, something that's fully conductive like copper, which very, very easily passes electrons. So the electrons pass, but they hit a resistor, they hit resistance, and they can't pass as well. They can only pass not as easily. And the way that I like to describe it is if you've ever been to a sports game, there's when everybody's entering the sports game, entering the ball field or anything else, you have a gate and everybody has to have their ticket. So when you get to the gate, there's a line. If there was no gate, there would be no line. So essentially, when you hit the gate, the people are essentially the voltage. Uh, they're pushing pressure on the gate they want to get in. But there's only so much bandwidth to that gate. One one person, one ticket at a time. So the people can pass through, but they can only pass through one at a time. And that's a simplified version of what a resistor is. But essentially, imagine you have a lot of people and just a few gates, and you're trying to pass those people through, much like electrons. You're passing them through something that doesn't necessarily want to conduct them through. And in doing so, when you pass that voltage through that resistance, you create current. And current is essentially the electrons, the flow, like water, the flow of water. So if you have a water spigot and you turn that water spigot to about half, you have about half of your water flowing about half of the potential that you can flow that water. So if you were to turn the spigot all the way off, that's would be infinite resistance because the water can't flow at all. If you turn it to half, then you have about half flow. And that is your current. That flow is your current. That's how much water. If you were to section off that hose to connect it to the spigot, that's your charge. And the charge is how many electrons you have in that section. And for the hose, it would be how much water you have in that section of hose. So the more current you have, the more water you have passing through the hose at any one point. And so just like the hose, electronics and electricity and current pass through a line, much like a hose, and there's resistance, much like the spigot, and the flow of the water, aka the flow of the electricity, is the current. Now let's talk about ground because nobody ever talks about ground. I've taken classes on electronics and ground is never really covered, and I think it's something that's very confusing. So ground in traditional electron flow, there's two types. There's traditional electron flow, and then there's just electron flow. So you can look at it two ways. And it really depends on a grander scale. If you zoom out, uh, it, the electron flow way is how a engineer would tackle his design or her design. However, for working on electronics, electron flow doesn't really matter as much. You can use the traditional flow. And I should have just called it traditional. That's positive to negative. When you're looking at two poles, much like on the symbol for voltage, you can see a positive, which is the plus, and the negative, which is the minus sign. And the way you would look at it is that electrons flow from that positive plus to the negative. And what you're really doing is the electrons are coming from the negative side, traveling to the positive. And the negative side is also where ground is usually contained. Again, referring to water, you can think of ground as a well or a water tank. And inside that well is an infinite amount of water. And all sources lead to that well or that water. And so you would think of ground as kind of the source of all the water that you have. And in electronics, it would be the source of the electrons. So ground is shared by all the components in an electronic circuit. All the components in an electronic circuit might not share the same positive terminal, but they all share the same ground terminal. So when you are shorted to ground, essentially your electronic has a leak in its hose. It has a leak in its in somewhere in its line, and all that electricity is flowing into back into the pool instead of going to its destination. So think of ground as the well, the pool, the water tank. It's the source. And so you have to have a source in order to have a means of providing whatever it is, whether it be water or electricity. So, one more thing I want to talk about is that voltage, resistance, and current, there's a math equation which I will show about the relation between voltage, resistance, and current, in that if you divide voltage by resistance, you'll get current, and if you divide voltage by current, you'll get resistance. So they are all tied together mathematically as well.